Hello and welcome to a new episode of my screencast. Today I will show you the for next loop in detail. The question is, why do we need the for next loop? And the answer is, we use the for next statement if we want to repeat a group of statements multiple times. Let me show you the for next loop in 4 different examples. In the first one, we add up all numbers from 1 to 10 and show the result to the user. So, message box, the sum of numbers from 1 to 10 is 55. In the second one, we add up all even numbers from 1 to 10. So, the sum of even numbers from 1 to 10 is 30. The third one is a simple countdown timer that prints the numbers from 10 to 1 to the immediate window of the VBA editor. Countdown timer, and in the immediate window the numbers from 10 to 1 descending are printed. In the last example, random numbers from 1 to 20 are generated, and we have 10 attempts to get one that is 19 or 20. If we succeed, the attempt we succeed is shown in a message box. Otherwise, a failure message is shown. Let's try. Number 19 found in attempt 5. Once again, in attempt 9. Number 20 is found in attempt 3. And, well, we are lucky this time. And in this try, we haven't found a random number of 19 or 20. Before we begin to write VBA code, let us define what we will do. We want to add up all numbers from 1 to 10. We will write a macro with the name SUMNumbers. We need a variable for the sum of the numbers. Because the numbers we sum up are integers, the variable will be of type integer. We create code that sums up the values from 1 to 10. And after calculating the result, we will show it to the user in a message box. So let us start to create our macro in a new workbook. First, we open the Visual Basic editor with Alt F11. And we insert a new module with Insert Module, and we will name it Main. The first line in a module is, as always, option explicit to force variable declaration. Now it's time to begin our macro with SUMNumbers. And hitting enter completes the macro definition with a parenthesis and the end sub. I insert some blank lines between the sub and the end sub to have some room for the code we write. At the very first beginning, we have to declare a variable that contains the sum of the summed up numbers. I write dim sum as int. I use the space key for the auto-completion, so I only have to type int, and then I hit the space key to get the full word integer. So I press the space key and it is completed. And hit enter. Before using a variable, it is a good practice to assign a value to that variable. By default, an integer variable has the value of 0, but explicitly assigning a value is another puzzle piece of a good styled code. With sum equals 0, we set the sum to 0. Now we will add the numbers from 1 to 10. You may think you could do this by sum equals 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Well, this is a valid solution. But think of summing up the numbers from 1 to 1000 or even 1 to 1 million, then this kind of solution is not really the best one. This is the moment where the for next loop comes in handy. So let us first delete this not so optimal solution. Let's have a short look at the syntax of the for next loop. It starts with the keyword for, followed by a loop variable, which I will explain in a moment, and then an equal sign. Now follows the start value, the keyword to, and the end value. The loop is ended by the keyword next and the above defined loop variable. The program flow is as follows. At the begin, the start value is assigned to the loop variable. Normally you use an integer variable with a single character, which is M, N, O or P. The loop variable will be incremented automatically at the end of the loop. This means that the loop is run as often as values are between the start value and the end value. And it means also that the loop variable will hold all numbers from the start value to the end value. Then the code between the for and the next is executed. At the next line, the content of the loop variable is checked against the end value. If these are not equal, then the loop variable is increased by 1 and the code is executed once more. If the content of the loop variable is equal to the end value, then the loop is terminated and the line after the next is executed. How do we now transfer this theoretical explanation into a practical solution? At first we know that we have to use a loop variable. I will insert a dim n as integer and head back to the line below the sum equals 0 line. Then for, now the loop variable n equals all integer values from 1 to 10 and do something up to the next n. This is the outline of our for next statement. Now, what should be done when n has every integer value from 1 to 10? We add the current value of the loop variable to our sum with sum equals sum plus n. This increments the sum by the loop variable. At last we want to show the result to the user with a simple message box. With msg box, the sum of the numbers from 1 to 10 is blank and sum, comma, VBA only, comma, title, well, some numbers, and enter. Let us recap the macro. We named the macro some numbers. Then we declared an integer variable that contains the sum of the numbers. Then there is a loop variable for the for next statement. Before using the sum variable, it is a good habit to set it to a defined state. Now we begin the loop with the loop variable n that will have all integer values from 1 to 10. In the loop, the sum is increased in every loop pass by the amount of n. With next n, the end of the for statement is defined, and at this point the value of n is tested against the end value of 10. If n is not equal the end value, it is automatically incremented by 1 and the content of the loop is run again. If the end value is reached, the macro continues with the message box. Let us start now the macro. The cursor is located inside the macro, so we can press F5 to start our macro. The message box shows us the correct result of 55. The sum of the numbers from 1 to 10 is 55. So pressing OK ends the macro. To see the exact way of the program flow, we can use the debugging. If the debugging toolbar is not shown, right-click on an empty space in the toolbar and right mouse click and select Debug. In our case, the Debug toolbar is shown. As we want to watch the content of the sum and our loop variable at all times, we will add two watches. I right-click on the sum and add watch. I stick with the settings and press OK. And just the same I will do with the loop variable n. Right-click on n, add watch, and press OK. On debugging, I have now the content of both variables at all times inside. Because I want to single step through my macro, I do not start with F5. Instead I use F8 for step into. We see the subline of our macro is with a yellow background. This indicates that you are in debug mode and the macro is halted at the specific line. And that command will be executed next. Each press of F8 executes the highlighted line and advances to the next program step. By pressing F8 we get to sum equals 0. Then to the begin of our for next loop. We see in the watches window that n and sum are currently 0. I press F8 and you see that the value of n changed to 1. Pressing F8 adds the content of n, currently 1, to the sum. This means that both are valued 1. In the next step, n is checked against the end value of 10. It's not equal, so it's incremented and the program will be continued with the sum line. So I press F8 and you see the next line to be executed is once again the sum line. We see in the watches window that n now has the value of 2 and the sum is at 1. Pressing F8 executes this line and the value of n, 2 in the moment, is added to the sum, which results in the value of 3, as you see in the watches window. I will now slowly step through the loop without commenting every line until n has the value of 10. Please have a look at the program pointer and the watch window. N has now the value of 10. And we do the last adding and we see the sum is 55. What happens now at the next command? As n has reached the end condition of 10, the loop is not run once again and the macro is continued with the message box. From this point on, I will no longer single step through the code, so I press F5 to run the macro. We see the message box with the result, and by pressing OK, we are at the end of the macro. You see, the for next loop is not that hard to understand. In the next example, let us add all even numbers from 1 to 10 in a macro called add even numbers. First, I will delete these two watches expressions, so delete and close the watches window. Then I will delete that blank lines at the end, and I will start with sub add even numbers. Pressing enter, and for the start I am a little bit lazy and copy the full content of the first example to the second one. Oops, copying and Ctrl V inserting. Now it's time to adapt the prompt string a little bit to the sum of even numbers from 1 to 10 is sum, and at the end the title will be some even numbers. Our task is to sum up all even numbers from 1 to 10. This means that we want to add 2, 4, 6, 8 and 10. To start with a value of 1 in the for next loop is not really appropriate. So we change the 1 to a 2. But we have still to consider that only every other value should be added. As we know, the normal for next loop looks like this. That we can handle increments other than 1, we have to use the step function of the for next loop. The step value can be any integer number, positive or negative. With a negative step size, the start value could be higher than the end value. After the end value of 10, we add step 2. This means that at the next command, not automatically, 1 is added to the loop variable. It means that the step value is added to the loop variable. In our case, with starting from 2, and we'll have the values 2, 4, 6, 8 and 10. If I add these, the result should be 2, 6, 12, 20, 30. So our result should be 30. The cursor is located in the macro, and I can run the macro with F5. And we are happy to see that we are right. This concludes the second example. In the third example, I will show you how we can achieve a countdown timer that prints the values from 10 to 1 to the immediate window. Scrolling to the end of the module, I start with a new macro. Well, some blank lines to start at the very beginning of the page. Well, we name it sub countdown. What a simple name. I know that I will use a loop variable, so I declare dim n as integer and start with my for loop with for n equals. We want to show the numbers from 10 to 1 descending, so 10 to 1. And we use the step command once again. What is the step size? -1. Exactly. Immediately after hitting return, I write the next n, that I do not forget it. I'll move up one row and debug dot print, and what will I print? N, of course. That's the whole countdown timer. I press F5. Well, I didn't see anything. What did I miss? Control G for the immediate window. And we see the result of our previous run. I will delete it. Cursor back to my macro and I hit F5 once again. And you see, it really works. We have a countdown timer from 10 to 1. So easy is a countdown timer. Before we start with our very last example, I will close the immediate window and show an empty page. Sometimes it may occur that you have to end a for next loop premature. Maybe a loop has to be run from 1 to 1000 and at the 435th run something happens that makes the other 565 runs obsolete. So it would be a waste of time to continue the loop. But the loop has to be interrupted and must not be continued to prevent errors or misbehavior. So we need a mechanism to terminate the for next loop. Our task to solve is as follows. We have to find a random number that is 19 or 20 in 10 attempts maximum. Of course, we have to create an integer random number from 1 to 20. We have to show a dialog box how many tries we needed, or if no random number has been found within 10 attempts. And we will name our sub find random number. We start with the declaration of the sub with sub find random number and hitting enter. A little bit of room in between, and we declare first the loop variable n dim n as integer. Then we know that we have a random number which we will name, well, dim r number as integer. Then we know that we will have two different messages. I will only use a single message box, so I need a string variable with dim message as string. At very first, we initialize the random number generator. Please notice that you should always initialize the random number generator when using random numbers. And we initialize the random number generator with randomize. In the next step, we create the for next loop from 1 to 10 because we have only 10 attempts for finding a valid number. For n equals 1 to 10 and next. As you see, I didn't use the loop variable after the next statement. You do not have to use the loop variable after next. Leaving out the variable will increase the performance and does not reduce any function at all. So for all upcoming usage, I will no longer use the loop variable after next. Now we generate a random number and we will assign it to our variable. So r number equals rnd. And we generated a random number. Random numbers are always between 0 and 1. We have to multiply the random number by 20 times 20. Because a random number is not an integer, we have to convert it to an integer with, keep a little space, int, and convert the whole statement to integer. But now we run into a new problem. Because the random number is between 0 and 0.9999999 and so on, we get random numbers from 0 to 19, but we want them from 1 to 20. Therefore, we have to add 1 to the result with plus 1. At this moment, we have a loop that runs 10 times and produces 10 random numbers from 1 to 20. But we want to exit the for loop when we have a random number greater equal 19. Let us first insert the condition when we will have to terminate the loop. In our case, this is if our number greater equal 19, then and if. You see that I immediately inserted the and if statements after entering the if-then line. When I do so, I will never forget to add the and if. Now we can catch the case when the random number is greater equal 19. What will we do now? Well, we want to exit the for loop and continue with the program afterwards. We want to exit the for loop. This command exits the for loop and continues the macro right below the next. We run now through the loop and exit if a random number which fits was found. We only have now to manage which message should be displayed to the user. We have two possible cases. First, a number was found. Second, no number was found. How can we see which state we have? That's simple. If a random number was found, then the loop variable n shows us in which path the number was found. If no number was found, then the loop variable is 1 greater than the end value. Therefore, we will check if the loop variable is less equal 10. In that case, we were successful. In any other case, we were not successful. This leads us to if n less equals, less equal 10, then else and if. I first wrote the condition, then the else, and then the end if. And now I fill the gaps. If n is less equal 10, then message equals random number and our number and found in attempt and n. In any other case, message equals no valid random number found. As last step, we will show the message box to the user with msg box message VBA only and title random numbers. Let us recap the macro. First, we declare an integer variable for our for next loop. Then we declare a variable that holds the generated random number. The last variable we declare is a string that contains the message shown to the user. We initialize the random number generator to be sure to get always different random numbers. We start a loop which runs 10 times. We generate a random number that is between 0 and 0.9999 and so on, and multiply that by 20. Convert it to an integer, but now we have a random number between 0 and 19, and so we have to add 1 to the result to get a random number between 1 and 20. The random number is assigned to the variable r number. We test if the random number is greater or equal 19, which is the condition to stop the loop. If this condition is met, we exit the for loop and continue the line below the next statement. The and if statement closes the if part, and the next statement ends the for loop. Now we check if we have less equal 10 runs, which indicates that a valid random number was found. In that case, we assign the message random number, the number we found in attempt, and the content of the loop variable that indicated in which path we found the value. In any other case, we assign to the message variable no valid random number found. In the very last step, we display the message to the user. Let us start the macro now with F5 and see what happens. I press F5, random number 19 found in attempt 5. I click on OK and let's run that macro multiple times. Once again, no valid number found. Once again, wow, we were lucky. Number 20 found in attempt 1. Once again, not so lucky, not so lucky, not so lucky. Well, but now random number 19 found in attempt 3. And so we are at the end of the last example. This concludes the for next statement, the for next with step, and the exit for statement. Thank you for watching. See you next time.